In this tutorial, we're going to look at something called Address Resolution Protocol, or ARP. ARP is used to help send packets within a local network, and we'll give an example of what role ARP plays by an example of trying to send a ping packet from one computer in a small LAN to another. So let's suppose we're on PC1 and we have a command window up and we type ping 172.16.22.107. So I want to send in a echo request to, or a ping packet to PC3. So when it gets the packet, it'll respond with the same information it was sent. And ping is used just mostly to find out if a workstation is active and operating properly. Now, one of the problems is that PC1, yes, can send or construct a frame, or sorry, a packet. And so let's suppose it wants to construct a packet. And ping is also called an echo request. I'll just put ER for echo request. And we need some addressing. So the destination address for this ping is going to be this address here, 172.16.22.107. I'll just put the 107 here. Can't put everything in there. And the source is the network. We're talking packets, so this is at the network level. So the source is 102, PC1. And then PC1 cannot just send a packet on the network because NICs don't work at layer 3. They only respond to frames and destination addresses that have media access control layer addressing. So PC1 has to add MAC layer addressing, destination and source. Now, it knows the source, it knows its own MAC address is 50. I won't put the whole MAC address here, just use the last two numbers. But it doesn't know the destination MAC address, and this is where ARP comes in. So when this happens, what has to occur first is that PC1 has to find out the MAC address of PC3. And it does that using an ARP frame. Now, what's an ARP frame? Well, an ARP frame has a frame type which says, hey, I'm an ARP frame. It has source and destination MAC address. I'll just put in the source because this is being sent. This is an ARP being sent from PC1. It has the layer 3 addressing. It has the destination and source layer 3, 107, 102. And really it's asking a question. What it's doing is it's asking the question, who out there is at address 172.16.22.107 and what's your MAC address? So what is your MAC? So that binary question is inside this frame. Now what does it use for a destination? Well, it doesn't know which machine has it. So it uses all ones in the MAC address. So this is the broadcast address. And this is an ARP frame. So this ARP frame is sent onto the network, and all the hub does is it electrically just sends it out all its interfaces. So the ARP gets here, and the ARP gets here. Now what happens then, we'll look at PC2 first. It looks at the destination of the frame. Is it the same as its address? No, so it's the first question it asks. However, it also looks to see if it's a broadcast. It is, it's all ones. So since it's all ones, it starts to process it. It's an ARP frame. It's asking the question, do you have IP address 107? And it doesn't. It looks at its own IP address. It's 104. So it now discards that frame. That frame came to PC3. So PC3 basically asks the same question, but now when it comes up to the question about the layer 3 addressing, it says, yes, I'm 107. So it sends back an ARP reply. And now it sends it back because it knows where this ARP came from. It sends it back to the MAC address here, 50. Its MAC address is, I'll just put the last two numbers, 18, right here. It's an ARP reply. Its destination, it's going to 102, and it's from 107. And it says, hey, that's me. So an ARP reply comes back from here. And even though that ARP reply goes here, it's now a directed frame. This one ignores it because the destination address is not it. It's not a broadcast. And the ARP goes back here. Now PC1 knows the MAC layer address that it needs to send to. So it goes and continues to complete its frame here. And now it can put in the destination address of this echo request in here. And that's going to be .18. It also does something else. It also keeps something called an ARP Cache. Which is a file in memory which temporarily holds information that it's received from ARP. So it found out that 107, that is 172.16.22.107, had this MAC address. And I won't put the whole numbers here, I'll just put .18. So if it needs to send something to 107, IP address 107, a few seconds later, it won't need to make another ARP request and get a reply back. It can just look in its cache. So the very first thing, in fact, if it was doing a ping, is it would first look in its ARP cache. However, we assumed that the ARP cache was empty. Now that I can have constructed the frame here, this orange frame, that orange frame goes out on the network. And so this is my ping or my echo request frame with the packet information in here. And it puts a little error checking some frame information here. That frame goes down here. However, if you look at the destination address, it's 0.18. That's not PC2's MAC address, so it's ignored. It goes down here to PC3. PC3 says, I've got this frame, the destination address 0.18, that's me, so I should process it. It then takes out this packet from the frame. It then processes it further and looks at the destination IP address. It's 107. Again, that matches its IP address. And it says, I'll process this further. This is the actual payload in here. And it's an echo request. What happens is this constructs a frame with an echo reply the same way and goes back to PC1. This also, from this exchange, is keeping ARP information, so it also has a cache. And it has learned that 102 has a MAC address of 50. Again, I haven't put all the numbers here. So it's 172.16.22.102 would have this long media access control address. So ARP is necessary in a local network in order to find MAC addresses based on sending information between internet addresses. And what we're going to do next is we're going to look at an example of this sort of in real life. Okay, for an example here, we've got actually two machines. This little window here is from a Unix machine, and this window behind it is our Windows 8 second computer. And if I want to find the current IP address on Unix, I do ifconfig. I need to go back up a little bit. Whoops. A little bit here. And look at our Ethernet interface, EN0, and we can see this is at 102, and this is the MAC address of that interface. For the Windows machine, we would use ipconfig to find that information. We can see it's at 107, and it has does it give us? It's buried the MAC address in the IP version 6 here a little bit, so it's a little more difficult to tell. But we'll find that out. We'll find that out later. So what we're going to do is we're going to look at pinging from the Unix machine. I'm going to ping my Windows machine behind me. And I'm going to use, of course, so this is the same example we used in the tutorial. And we'll show some real world problems that happen here. Well, I'm trying to ping and I get some error. So one of the first things that happens, I have a very simple network, is I can't get to this. Usually when that happens, it's because there is something blocking ping from actually getting to this machine. And in this case, it's a firewall. So one of the first things we might have to look at is our firewall turned on or off. And in Windows, to look at your firewall, there's a number of places you can go, but Windows Firewall is one. But the Administrative Tools has a section down here called Windows Firewall with Advanced Security. And we want to go there to be able to turn off firewalls. So if we go here, we're going to see that there are three profiles that we can operate a Windows machine in. Domain, if we're attached into an enterprise network using Active Directory, which we aren't. A private profile and a public. So you need to know whether your machine is operating it with a public profile or private profile. That's beyond the scope here, but I happen to know I'm operating in the public profile. How do I turn off my firewall because my firewall is on? Because that's going to block any pings I want to do. We're going to turn that off. We're going to apply that. And I don't need this anymore. Now back to our Unix machine, we can actually look at ARP information by using an ARP command, ARP-A. And it sometimes takes a while to build. And I happen to be using this command a while ago. We're just going to remove an entry here from, this is the ARP cache. And using an ARP command, I can delete entries by using a -d 172.16.22.107. So we're going to remove that entry. Operation not permitted. Sometimes in the Unix world, you've taken some introductory courses on Unix and Linux, you need sort of root privileges. You can do that using a command called sudo. I didn't have enough permissions to do that command before, so we use sudo ARP -d 172.16.22.107. It's going to ask for a password, and that's just the crabdh, my user password. It is not the root password. Okay, so let's look at my ARP cache. So one of the first things that is going to happen when I issue a ping command from my Unix machine here is that it's going to look at the ARP cache to see if it's got an entry for 107, and it doesn't. So when I go ping 172.16.22.107, it's first going to look in the ARP cache and see that it has no entry. So now it's going to issue an ARP request. It's going to use a broadcast address. It's going to find out the MAC address, whoever is at IP address 107, and then it's going to use that to build the frame to make the actual ping packet, the echo request, and then it's going to get a response. Now we fixed the firewall, so whoops, we thought we fixed the firewall. We didn't fix the firewall, so we'll go back here, take a look again. Whoops, I turned off the domain profile but not the public profile. So another mistake, I have to hit the right tab, turn this off, whoops, apply it. Go back to my Unix machine, we'll try this ping again, and the ping now works. But what you didn't see behind the scenes is that it first had to do an ARP. And what you'll see now is that 107, it found it had this hardware address. Let's see if that's, we may not be able to tell that from here. IP config slash, let's see if we can get that physical address. Is right there. And we can see the physical or MAC address of my Windows machine 000C29 D1FC18. And now that resides in the ARP cache. So if I do subsequent pings to that address, the Unix machine does not need to do an ARP. It can simply go to its ARP cache, find this address, construct the frame, and send the ping information out directly. Oh, there we are. So that's an example of how ARP works. Now to give you a little something that you can do on your own. Here's the task, and you'll do this on your Windows PC. You could also do it on a Mac if you wanted to, but I want you to use the ARP command at a terminal or console session. So on your machine, find another machine on your local network, and I'll call this machine blue. Record its MAC address and its IP address. So you can go on the other machine or have a lab partner tell you the MAC and IP address. You would use the IP config if you're using Windows. Now, on your machine, use an ARP command to see if your ARP cache has an entry for blue. If it does, delete it. And if you have to delete it, then verify that your ARP cache doesn't have an entry for blue. Once it doesn't have an entry, I want you to ping blue. Now, if that doesn't work right away, then you have to look on blue and see if its firewall's up. If its firewall's up, then you'll have to disable the firewall. But once the ping works, go back and view your ARP cache, and you should see for the IP address for blue, you should verify that the MAC address is what you recorded in step 1. Finally, delete the ARP cache entry for blue, just so you know how to delete ARP entries. You can save your command line session as a file. You can start your command line session by just hitting CLS and it will clear everything. And then you can do all these things. And then you can save it in a file and submit it to your instructor.